Welcome to the JavaScript game development series. You can use the link below and you get this interface where on the left you can type some code, for example alert, hello. So if you would type this line by itself it does nothing, we need to run it. So on the right here you have the restart and the run button. If I click run, you'll see we get a little pop-up saying hello. So this is actually a function call and this is the function parameter. You can change this to anything you'd like. So for example, we change the message here in the function alert. You can recognize a function by, it starts with a name and then it has those parentheses. So you see the closing parenthesis and the opening parenthesis. Every JavaScript line has a semicolon at the end. If we click run, you'll see the message changed. So it's a function that displays a box and it displays whatever you put between the quotes. Now you'll see here a little mouse, so there's a little video game. We have a function to move that mouse. So we can type move and then the direction, so right, left, top or up. So that's the parameter we can do. And because JavaScript executes everything right at the same time, you want to type await in front of it. So that awaits the mouse to move. So if we run it, you'll see it did one step. Now what if you want to do it multiple steps? So you could simply call the function multiple times. And now we have a little program. Now you want to be very careful with typos. So here you'll see this is spelled wrong, so it wouldn't do anything. See, if I click run, nothing happens. So make sure you don't have any typos. You can see with the highlighting color. So this will start at the top and move one step right, then it would go the second line and the third line. So if we click run, you'll see it moves towards the right. Now you'll see we need one more step. So we click restart, make sure to restart so it starts from the same starting point. So we need another right step. So if I click, you'll see it moves all the way to the right. Now of course we can make it move back if you want to. So if you would type left, you'll see it will move into the other direction. But in this case we want to walk towards the cheese. So we'll want to call it another few times, but this time we don't need it to move more right, we need it to move down. Right? So we change the parameter to down. Now notice that it always has a wait for it, so it waits for the function to finish. If you don't do it, JavaScript will run everything at once. So we want to move some steps down. You'll see now if we run it, we completed the level. And you'll see it goes into the next level. Now there are quite some levels, so if you use the link below you can try it on your own and you can play around with function calls. If you click on the hint button, you'll see all the options and some more explanation about the function calls. So this just calls the move function with the parameter, and of course there's 4 options: up, down, left, right. And you can use functions after another, right? So here we can use down several times, and then we'll need to move quite a lot of right steps. So we would have a lot of right steps. So something like this. If you run it, you'll see it moves right, and now it's some steps too many, so this is not a correct program. We would have to remove something from the program. And you'll see a program is always executed top down, so it starts here and then does step by step. So the mouse just follows the program you give to it. So of course the idea is to complete all the levels in this game. There are quite some levels, but it'll give you some idea of how computer programs work. And in this case, we only need one function, the move function, but make sure to wait for it and as a parameter specify the direction. Now don't forget the semicolon, otherwise it might not run, and be careful with typos. So that's it for this video. If you like this video, keep watching the other videos. There's gonna be a lot more JavaScript series. Let's take a look at variables. Now remember in the last video we used the alert message to show some information. So anything between text, we could show that to the screen. If we run it, you'll see it shows that on the screen. Now what is a variable? A variable is simply a container for a value. For example, we could have a variable message, which we create in this fashion, and then this would be a variable. Now it's not used by default, so we would have to change the parameter here to message, and then it will show the message we define here. You see, you get that pop-up. Now functions can be called multiple times, and variables can be reused, so it's not like it only uses it once. Now it would show the message 3 or 4 times. So you see, we can reuse variable. In this case we have a variable that contains this content, so this value, and the name of the variable is message. So variables can be used in a function. So remember we used this command await move right to make the mouse move right. So this, instead of typing it literally, it could be a variable. So we could have a variable r which has the value right, and then in the parameter we specify r. So that would be a little bit shorter to type. You'll see that's one step. So instead of typing right, we could do this, and then it's using the variable r to show, or sorry, to move. Now variables, as the name implies, are variable, so we can change the value of r. For example, it could be down, and then you'll see instead of going down, it moves downwards. Now you want to make sure that your variables actually make sense, the name. So r for down doesn't make a lot of sense, so you would want to keep it right or be more explicit in the variable names. So it can be one character, two characters, three characters, and so on. It can have an uppercase, lowercase. You can define different variable names, but variable names cannot start with a number. So if we type 3, you'll see this, that is not blue anymore, it doesn't work. It has to start with a letter, any alphabetic letter. Now it can have a number at the end, but it cannot have a number in the beginning of the name of the variable. So that's the idea of a variable. So it can be any variable. For example, x is 5, can define another variable, and then we can alert to x plus y. So we have two variables here, x and y, with different content, and if we run it, it should tell us the total. And there you go. So you can do also kind of basic arithmetics with variables if you want to. So you can have more than one variables, and we can just to echo one or to show one, you would just type alert x and y, and that shows the variable contents. So that's the idea of variables. It can contain numbers, so in this case 5 and 2, but they could also be messages. So instead of a number, you can also have some text. That works as well. So it can be either text or numeric, but it's just a container for that value. So that's the idea of a variable. An if statement, that's what we're going to talk about in this video. In life you make decisions all the time. Now computer programs, they can make decisions too. For example, here in this little mouse game, there could be a decision which solution to do. There could be a solution first right and then down, or first down and then right and then down again. So different decisions, right? Do we go right or do we go down? So you can define some variable, let's say solution is 0, and then we can make a decision. Computers make decisions using if statements. Now you might hear it in the word if is the keyword here. So if solution is equal to 0, so in here we do the first solution, else, or we could simply say if solution is equal to 1, do the other solution. Now to visualize this, we can put an alert box here. So alert choice. And to make it more clear, let's start counting from 1. Even though computers start counting from 0, humans count from 1, right? So let's change that. So this would be the first choice, and this would be the second choice. So now we have two if statements. So if the solution is equal to 1, and if the solution is equal to 2. So it either executes this code or it executes this code. So the code between those curly brackets is executed. In this case, there's only an alert box between there. So let's say we set it to 1 and run. You'll see we get the first choice, and we don't get the second one. So this is not executed. It says solution is 1, so it sets solution to 1, goes to line 4. If solution is 1, does this. And then it asks, is solution 2? It's not, because we set it to 1, so it skips that. And then it goes to line 13. If we were to set it to 2, the opposite would happen. It would skip line 4, solution is not 1. It would go straight to line 9, and solution is 2, so it would execute that and run. So if we click run, you'll see we don't see first choice, we only see the second choice. So that's an if statement. It runs code, but only if a certain decision is made. So in this case the decision is solution is 2, so it does this code and it doesn't do this code. So here we could implement our solutions. So it can be multiple lines of code in a decision, right? It can be, if you make a decision, you can make multiple steps after that. So for example, this could be the default mode. So first write several times. Make sure to type await in front. And then downwards a few times. Now in order just to show you, I won't let it finish the whole level, so let's do one down step. For the other solution, maybe we want to go down first and then right. So await, move down. So that's several times. And then some right steps. So now we have an if statement, right? So we have two different codes that are either executed. If solution is 2, it jumps to it skips this one because it's not 1, so it goes here. Is 2, it executes these one by one. So let's see if that works. If we click run, you'll see it says second choice, and it goes down and then to the right. Now if we restart it and we change it to 1, it goes here to line 4. Solution is equal to 1. The equality check in JavaScript is 3 equality signs. And then it runs these steps one by one. So if we run it, you see first choice, and it does those one by one. So that's an if statement. Now what if choice is not 1 or 2? For example 3 or 34, it doesn't matter, any other number. You'll see then it doesn't do anything. So in the case solution is 3, solution is not 1, so it skips all of this. Then it goes here, line 13, line 14, solution is not 2, it skips all of this, and it just finishes the program. Right, so this is how computers make decisions, using those if statements, and then based on any variable. So in this case we have the variable solution, but it could be any other, right? So for example, let's say a more real-life scenario, we could have, say, weather, let's say to rain. So if weather is equal to rain, maybe we stay inside. If the weather would be something else, like sunny, maybe go to the beach. So then depending on the weather, we do different things. So we make those kind of decisions, and this is how it would look in a computer. So using if statements, you can execute blocks of codes depending on the value of a variable. So in this case, the variable weather, and make sure to type let in front for the variable definition. So that's variables, that's if statements, so just how the computer makes decisions. In the previous video you saw how computers make decisions using if statements. So we could say if the solution is 1, 2, 3, 4, if solution is equal to 1, you'll see I tried here 3 equality symbols, that's for the if statements, equality check in JavaScript. And then anything between these brackets would be executed. If solution is 1, and then we would copy it and check for solution 2. So in this case, solution 2. Now depending on if solution is set to 1 or 2, it will either execute this one or this one. So you'll see now it's set to 1, let solution is 1. If we run it, it says solution 1. If we were to change this, for example to 2, you'll see it skips the first one because solution is not 1, and then it jumps right here, solution is 2. You'll see solution is 2. It skipped the first one because solution is set to 2, and this checks if solution is 1, which is not, so it skips this whole thing. So you can do it like this, but another way to write it would be using the else keyword. So we type else, solution is 2. So in this case, the solution is either 1 or anything else, then it is solution 2. So you'll see now it says solution 2. It skips the first one because solution is not 1. And it's the else case, it is not 1. So then it executes this part. And it is solution 2. But it's actually anything else, right? So it could also be, for example, 5. And it would still say solution 2 because solution is not 1. So it skips that and it goes straight into the else. So any other case that is not 1. And if it's 1, of course, it does the first one. So you'll see solution 1. So how can you also combine that with solution 2 and the other situations? So we could say else if solution is equal to 2, you can remove that, else maybe not possible. Right, so now the solution can either be 1, if solution is 1 it does this, solution is 1, so this would be true, it runs this line of code. If solution is 2, it runs this line of code, and in all the other cases it runs this line of code. So let's try that. Solution is 1, you'll see solution is 1. And it also says not possible. So in this case there's a bug. So solution is 1, and instead of if we should have else if. Otherwise it's simply an if statement that is written like this. So you want to make sure you type else if there. If you run it, you'll see solution is 1, finished. Solution is not 1, or in this case solution is 1, so it runs this and finishes. If we set it to 2, it continues in this code. Solution is not 1, else, don't forget the else like I just did. Else, if the solution is 2, it runs this code. So you'll see it returns solution 2. If we make it larger, for example 8, and then run it, you'll see it outputs not possible. So solution 1 is not true, solution 2 is not true, so then the else is true, which you can basically catch boundary cases, so anything else, any inputs that are not possible in this case, because there's only 2 possible solutions unless you start to walk in circles or some weird ways. So that's what you can use the else for. So it's a way to combine if statements and also to evaluate other cases. So in this case else if the solution is 2, or else in case there is any other possibilities. Now you could have also more solutions. For example, if solution is equal to 3, and then some text in there, right? So alert solution 3. So then it would work. Whatever value you set to solution, either it runs this one, this case, or it runs this case, or finally, if not, it's not 1, 2, or 3, then it runs this part of the code. So that's the else keyword that you can combine with the if statement. Let's come back to the series. In this video, we'll explain while loops. So we can have code here, like here we call the function move, and it have the parameter right. If we run it, you'll see it takes a step right. Now if we were to solve this puzzle, we would have to do that many times, and also downwards. So we would have something like this. And then some downward step. So you see it gets quite repetitive, and the longer the level gets, the more repetitive steps you have, right? So if we run this, you'll see it solves the level, but at the same time it looks quite repetitive in code. And so what if instead you have a very large level, you could have a lot of repetitive steps, many more than these. For example, maybe it's a very huge level, so you would have 10 steps right, 5 steps down, 7 steps left, and so on. So that gets quickly very, very repetitive. So what you can do is repeat code. So instead of having some code like this, if you have a very large level, you could simply have repeat code. So we could say let I is 0, I is here a counter variable, so simply something that counts 1, 2, 3, 4, 5, and so on. So it's like a container, I contains a value. Now we use the while loop, so we want to repeat this line of code. We use the while loop, so type while. Then it needs a condition, so while I is, for example, smaller than 5. And then it needs to know what is part of the function, so we could type the begin symbol, that looks like this, so that's the begin of the while loop. And then, as you might have guessed, this is the end of the while loop. Now, this wouldn't work yet, because I will always be 0, so we need to make sure that I increases by 1. Now, when you run this program, don't forget the await keyword, so await in front of move, and also make sure that we have I that is increasing. Otherwise it stays in this loop forever. Otherwise I is 0, I is always 0, and it will stay forever in the loop. So you want to make sure to increase I, and also to type await before the move function. Okay, so if we run this, you'll see this line of code gets repeated 5 times. So you'll see it's repeated 5 times. And you can do that for the down steps as well. So if we say I is 0 again, start counting from 0, and while it's smaller than, well, in this case I think 3 will do, just repeat the down steps. So you'll see this can be smaller if you have a lot of steps. So if you have like 100 steps, this would be a smaller way to write it. Now in this case, in just 5 steps, okay, it might not really be beneficial, or for 3 steps we can simply type it in 3 lines. But for a large level, so if you have a very big maze, then this could be a more convenient way to write it, where you simply repeat the command several times. So and as you progress in the game, the levels get larger and larger, so it becomes more and more reasonable to use the while loop to repeat steps. So while all it does is repeat code. So for example, while working, you would have something like this. While working, work, right? Something like that. So the while loop, it will continue the loop until the condition changes. Now in this case we used I is 0, so we used I as a variable, but it can be any variable. So if you want, instead of I, you could say, for example, steps. So while the steps is smaller than 5, and then increase the steps by 1. So that's the idea of a while loop. It simply repeats the code between the parentheses until the condition here is true. So in this case it's true if steps is greater or equal to 5. You see, in this case it does the steps, but it doesn't move past the block here. But it does them anyway, and then every time it's walking against the wall. So that's what a while loop is. It's simply a way to repeat one or more lines of code until a condition is true, and you want to make sure with the while loop to always increase the counter. So the steps in this case is the counter variable. So in this case, create a variable with let in front, so let steps, and then is the value. Now let's create our own function. So here, if you use the link below, you'll get this version of the game. It's very similar. The only difference is that the theme changed. So here we have an astronaut that has to get to the rocket. But it's the same idea. So if you run it, you'll see it moved 1 step to the right. And you can define your program. So whatever steps you want. Right, so you can have some program like this that starts on the top and then moves all the way to line 7. And you'll see if we run it, it executes the program. Now this can get very tedious, so in another video we used a while loop to solve this, but it also can be tedious to write. So you'll see here move right, move right, move right. So if we would type that manually, it would be a bit tedious. So we can create our own function. So we type async function and then the name of the function. For example, right. So you'll see I use this parenthesis, that's the begin of the function, and this is the end of the function. This is the function name, and this is just standard. So in here we can do any command. In this case we want to do the right command. Then what we can do is remove all of this and simply type right. Now if we run it, you'll see it does 1 step right, and we can then run it, and it will simply call that function, and in the function it moves right. So that works well. Now you might think that we can type await left. That's not the case because there's no function left, right? So this wouldn't run at all. So if you'll see it doesn't move left at all because it's not defined. We would have to define left. So we would need another function left where it contains one call left. So if you run this, you'll see now indeed it does go left at the end. You'll see right, left, and left here is a function that does a step left. So in JavaScript you want to make sure about the syntax. If you have a typo, the code won't run. So make sure you have async in front, function, that there's no typo, and for the function call you want to make sure you have await in front. This is the begin and end of the function, so anything in between. The begin and end is part of the function left, and here anything in between is part of the function right. Okay, so you can define functions in that way. Now, of course, we can make it easier to write, but there's more cool things we can do with functions. So we can create a function that does X number of steps. You learned about the while loop before, so we can make a custom function. Function, it needs to have some name, maybe repeat, or let's change the name to M, because who wants to type a lot? So So this is the begin and the end of the function. Now in there we could simply call any move function, for example right, but let's say we want to do it a number of steps. So we would have a parameter here, let's say amount, then we can say let I is 0 while I is smaller than amount. So what we're trying to do here is simply repeat the number of steps given the amount. So we say m, for example 5 steps, and then if you run it you'll see it repeats 5 steps. So it calls the function m, and then it goes here m, and then the parameter 5 is the amount. It goes in the loop, starts at 0, the counter starts at 0, and then while it is smaller than the amount it moves right. Now you'll see one thing we forgot here. We have to increase I or it will stay in here forever. So make sure to increase I. If we restart it, you'll see it's running forever, so we need to refresh the page right now. So that happens when you don't increase I, it gets messed up. So you'll see it begins here, the function m with amount, I is 0, it repeats until the amount, in this case 5, and then it just moves right and increases by 1. So this one will move right. We can change this to mr, for example, and then we can make another one for down. So those are functions, and then we can, for example, move 8 steps down. Let's see what happens if we run it. So you'll see it starts at await mr. It doesn't execute functions right away, only when you call them. And we need one more step to reach this corner point. So let's increase it by 1. And you'll see it does take some time to write functions, but it can save you a lot of typing here, because now we're just telling how many steps right and down in these 2 lines. We would need another one for left and one for up. So we can add that. So we have 4 functions in total. So one for up, and we will need one for left. So then we have a bunch of functions. And we want 3 steps left. No, that was a little bug. So if we run it, you'll see it's now moving towards the rocket. You see 1 step too much, and we want to make sure that it moves up several steps, about 5. Okay, so now it will move right 6 steps, down 8 steps, left 2 steps, and up 5 steps using the functions we just defined. So if we run the program, you'll see it starts moving towards the right directions. So it can save you a lot of typing if you have functions, even though this looks like a lot of lines of code. Once you have functions, you can reuse them as many times as you want. So actually the program we have is just 4 lines of code instead of a lot. This is just our definition of the functions, but the actual things the program does is these steps. Now you'll see here I used very short function names. That's not necessary. You can make them more explicit. For example, we can call it big right and big down, big up, or whatever function name you feel is appropriate. So we change the function names here. And you want to make sure that if you change the function names, like we did here, you change them when you call them as well. Okay, so if we run it, you'll see it starts, it repeats all the steps that we defined, so it uses those functions. And functions can do anything you want, so it doesn't have to be specifically like moving the game. It can also be you have a simple function like, let's say example, and the function simply shows an alert box. Right, that's a function as well, so we could type await example. Then if we run it, you see we get an alert because that's the function we defined, function example. It only does alert. Once we close it, the rest of the program starts to run. So functions, you can think of them as just a collection of lines of code. So you'll see this is function right amount. It's just a bunch of lines of code. This function as well, this function as well, and this function as well. So all these functions have one parameter. It is possible for a function to have two parameters. So instead of having all these functions, what you can do is, for example, have another parameter, direction. Let's just name it big then. And then change this to the direction. So we can leave that one in. Let's say big 6, 8, and down. And then we have another parameter, direction here. So we can specify right, down, left, and up. So notice how the code got a lot shorter. And this one is of course completely optional. Let's remove that. So got a lot shorter because the function now takes two parameters. So sometimes redesigning a function can help you to make the code shorter. You'll see the program still works as it did before. So it has just one function now, big, with an amount and a direction. It uses a while loop to repeat the move steps. So you can play around with it, try to make your own function that moves the player around and see what happens.